So you can go through some more problems of this. That is orthogonal trajectory of Cartesian form for practice purpose. Answers are also given for your verification. So I can try these problems. So this particular problem, what we are showing, lambda is present. See, x square by a square plus lambda plus y square by b square plus lambda. And it is given lambda is a parameter, means you should concentrate to remove only lambda, not a and b. That is what you have to observe. Procedure is same. You have to differentiate, then write it in a particular standard form. Then you are not able to remove lambda. Like the previous problem, somewhere a you are not able to remove. Like that here lambda. Then put lambda value in the given problem. So you will come to know the dE. Then replace that dy by dx as minus dx by dy. And what and all the simplification possible. So then we can see the dE appearing like this. In this problem also, after replacing, the dE is the same. So it is called self-orthogonal. So, and one more question is the rectangular hyperbolas are mutually orthogonal trajectories. That means if you start with the first one, the second one will be the final answer. If you start the second one, suppose xy is equal to c square and do the procedure, then you will end up with the answer of orthogonal trajectory as x square minus y square equal to c square. So like this, you can have different problems. So we now discuss, after discussing the Cartesian form, that is the polar form. So how to do the orthogonal trajectory is a similar case with a different notation, that's it. So instead of x, y and a constant, we will be having now r, theta and a constant in the given relation. So if your problem is having r, theta and a constant, it is called as a polar form. Now a relation is given, that is a family of curves is given in terms of r, theta and a constant. Then how to find the OT, that is orthogonal trajectory, is same thing. We know that r is a function of theta, that's why differentiate with respect to theta and concentrate on eliminating the parameter called c. Now your equation will be having r, theta, and the differentiation of that is dr by d theta term. So now we need an orthogonal trajectory. As we know, the concept m1 into m2 is minus 1, wherein the slope m refers here tan theta. And we all know what is the tan theta here. As we have discussed in our syllabus, the first chapter, polar curves. What is tan theta? That is the angle between radius vector and the tangent. It is given by tan phi, that is 1 by r dr by d theta, right? So 1 by r dr by d theta is the cot phi. Then what is tan phi? R into d theta by dr. So replacing that, if it is r into d theta by dr is one of the slope, then what should be the other slope? It should be minus 1 by r into d theta by dr. So in order to have product of slopes is minus 1. So r into d theta by dr must be replaced as minus 1 by r d theta by dr. That means it should be minus r square d theta by dr. So replace dr by d theta by minus r square d theta by dr. So then whatever the dE obtained is called as dE of the orthogonal trajectory. Then like the previous methods, we can solve by variable separable or exact or linear or Bernoulli, whatever the equation suggests. So we'll see a problem. Find the orthogonal trajectory of r equals to a into 1 minus cos theta. So by seeing the problem, we can understand it is in polar form. Then immediately recollect what is to be substituted. So the first step is differentiate with respect to theta. So after differentiating, so dr by d theta a into that is minus of minus plus sine theta. So here still a is not removed. So get the value of a, that is 1 by sine theta dr by d theta, and substitute in the given equation. So this is the way that we have done here. If you are okay with the first chapter, like taking log on both sides, then it will be log r equals to log a plus log of 1 minus cos theta. Then differentiating with respect to theta, you'll get 1 by r dr by d theta, like how you have done in the first chapter, polar curves. Like that also you can do and get dr by d theta equation. So any one of the ways you can do, either directly from the problem you can differentiate, or taking log also you can do. But finally you need dr by d theta equation here. See, here we got dr by d theta like this. Now what we need to do? We have to replace dr by d theta by minus r square d theta by dr to get the d of orthogonal trajectory. So replace it like this. Then we see that this is the equation obtained by cancelling r throughout. Then just trying it for variable separable if it happens. Yes, now it became variable separable. Then directly integrate it. C1 by r dr we got cosecant theta minus tan theta. So differentiation of that is cosecant theta minus integral of cot theta we got. Integral cosecant is log of cosecant minus cot. Then integral here, integral cot is log of sine theta, right? So after doing the integration, writing the answer in terms of r, theta and the constant parameter. So gives us the solution. This is the orthogonal trajectory of the given curve. Just writing it in a standard form would be convenient instead of stopping at any step. See, here we have written 1 minus cos theta sine square theta and written sine square as 1 minus cos square. All that we have written so that it will be easy for our simplification. So that our answer will be in a standard form. So r into 1 minus cos theta is sine square, means again written as sine square, how to write 1 minus cos theta, how to write. So all that written simplification, 1 minus cos theta is 2 sine square theta by 2. Like that we have written here and made it as convenient form, like r equal to a constant into 1 plus cos theta. So like that also we can bring to a convenient form. So in the same format all the problems can be done. Just differentiating and removing the constant, that is a parameter. Then replacing dr by d theta as minus r square d theta by dr and solving the dE. So it's very simple. Any one question can come from here. So one from Cartesian and one from orthogonal trajectories will be asked in your exams. Okay. So these are the different questions that are listed. You can practice the same and check the answers also which are discussed.